This is your short video lesson on drawing Lewis structures that are a little bit more complicated than diatomic molecules and smaller compounds. So let's start with just remembering that you need to access your notes for the rules for doing our Lewis structures. So let's do CF4 first. So my first step is that I need to count my valence electrons. So carbon has 4 valence electrons and fluorine has 7. And there are 4 fluorines, so we multiply 7 times 4. So that gives us a total of 32 valence electrons. The next step that we're going to look at is figuring out which atom is the least electronegative. So we know that fluorine is the most electronegative atom on the periodic table, so we know carbon is our least electronegative. For the most part, carbon is probably going to be, if it is present in the compound, the central atom in most of our compounds. So we're going to put carbon in the middle, and then we're going to put fluorine around the outside. And I like to assume a tetrahedral shape until I look at my VSEPR shape at the end to see if I need to switch anything around. And so I'm going to just place fluorine around the outside in all 4 spots like it would be sharing with carbon. Then the next step is that I'm going to put the outer electron pairs on the outer atoms first. So I'm going to fill in with all of those electron pairs, so that gives me 24 electrons. And then I'm going to count and look at that I have 8 electrons left, and so now I can fill in on the central atom. So then my next step is to check to see, are all of my atoms happy? So my central atom has 8 electrons, and then all of my outside atoms also have 8 electrons, so everybody's happy. You don't need to do the red circles, that's okay. I was just showing that for the sake of making sure that you're looking at how to count those electrons. And then the next step is to change our dots to dashes. As you're going, if you know you're going to be sharing an electron pair with the central atom, and you'd prefer to put the dashes first, then go for it, that's okay. I'm just trying to show you based on the rules kind of how that works. So you can just start, if you're comfortable with that, putting in the dashes instead of the dots right away, instead of having to go back and erase. So what we're going to do is figure out our bond type. So if we look at our electronegativity periodic table, we know that carbon is 2.5 and fluorine is 4.0. We're going to do that subtraction, and then I know I have a polar covalent bond. One of the reasons why we're looking at bond type is to help us figure out where those electrons are going to hang out a little bit more. And so this is where we're going to identify our arrows. And so I know that fluorine is more electronegative than carbon, and so those electrons are going to hang out around fluorine far more often than they're going to hang out around carbon. And so I'm going to draw the arrows pointing towards fluorine. So again, just the arrows show where the most electronegative atom is. Then I'm going to look at the molecule type. So I'm going to look and see, is this molecule polar or nonpolar? And so in my Lewis structure there, hopefully you see that all of those molecules, all of those fluorines on the outside of that carbon look the same. And so remember, if it looks the same, it's a nonpolar molecule. Next thing I'm going to do is figure out my VSEPR shape. So I'm going to identify my central atom, and my central atom is going to be labeled A. And then I've got 4 things bonded to the central atom. And so if I look at my electronegativity periodic table, if I look at the back side, I'm going to be in the 4 things attached to the central atom section, and I look and see that I have no lone pairs, and so I know that my shape is AB4, which tells me it's tetrahedral. So that's all of the information that you need to have for every single one of these ions, every single one of these compounds and ions. So I'm going to show you how to draw the ion next. So let's look at our nitrate ion. Hopefully you remember that the nitrate ion is NO3-. So then let's figure out our valence electrons. Our valence electrons are 5 nitrogens and then 6 oxygens. There's 3 of those. So then I do that, but then I need to remember that because I've got that minus sign right there, that means I've added a total of 1 electron to the total, which gives me 24 total. My next step is to put the least electronegative in the middle, and then just right now, again, I'm assuming that tetrahedral-ish shape, and then I will redraw if necessary once I figure out my VSEPR shape. So then I'm going to fill in electron pairs around the outer atoms first. So I've used 18 electrons on the outer atoms, and I have 6 left. So then I'm going to go in and share the electrons with my central atom, and then the next thing I'm going to do is count to see if everybody's happy. So my oxygens are happy, but my central atom is not happy. And so if you remember, we need to flip electron pairs to create a double bond. And I can flip from any single one of these atoms, any single one of the oxygens, it doesn't matter, I can flip electron pairs from any of them. So I'm going to flip from this right-hand one first. So I'm going to flip an electron pair, and I'm going to check again to see if everybody's happy. So all of my oxygens are happy, and now because I have that double bond showing with that nitrogen and this oxygen, this nitrogen is happy. So notice I didn't need to flip electron pairs from all of them, I just needed to flip from one of them. So then my next step is going to redraw the dots with dashes. And then I need to check my VSEPR theory. So if you remember when we did oxygen, just O2, and we talked about those electron pairs repel each other around that atom to be as far away as possible. And so remember, you can't draw electron pairs on outer atoms like this, because at that 90-degree angle they are not as far away from each other as possible. And so those electron pairs will adjust around that, so you need to make sure that you redraw your electron pairs on this oxygen showing the most distance between them, and it's generally going to be at that angle. So hopefully that looks familiar, like the oxygen in when we drew water as well. Those electron pairs are going to situate themselves like that. So then what we're going to do is figure out the bond type. So the bond type has nothing to do with whether or not there's a single or double bond, and so we're just going to look at the electronegativity difference between the atom. And so I'm going to take nitrogen as 3.0 minus oxygen as 3.5. So that's 0.5, so that's a polar covalent bond. And then I'm going to look at the arrows, so I know that oxygen is more electronegative. So we are going to draw those arrows pointing towards the oxygen molecule. Then I'm going to look at my shape, so I'm going to assign my A, and then I'm going to look and see that I have three things attached to that central atom. And so my shape is AB3. I'm going to look at my VSEPR table, and it shows me that that's called trigonal planar. And so if you notice, this does not necessarily look like the trigonal planar drawing, so you've got to make sure that you're assessing that and that you redraw. One of the things about an ion that we want to show is I want to show that it has a charge on it, so I'm going to put the whole thing in brackets and just put that -1 on there, just showing that I know I have a Lewis structure that's a charged atom, so this nitrate ion is charged. And so also, again, we need to redraw this. So let's look at our VSEPR table, and it's just showing that it's a planar molecule where we've got all of the atoms coming off at equal angles around that nitrogen, and again I'm showing my Lewis structure there. Thank you for coming ready with those two examples done, and we will work on more examples on this sheet in class.